anyways, before we let you go, there's some things that Ms. Myers and I said that you guys needed to have for pre-calculus. And one is you need to know what the heck a radian measure is, how to convert to a radian, from a degree to a radian, radian to a degree. We're also going to hit the unit circle, so we'll talk about that. You'll see a little snippet of it today. And then we're going to jump over to the law of sines and the law of cosines. Things that you should already seen, hopefully, from your geometry class. I know some of you guys have not, so that's okay. We'll go over those as much as we can. That just gives us 1 day per section, so you guys can still get your review in and your testing in. And that will make us done all the way up through the next 2 weeks. So that way, on that finals week, you'll do your written portion, and then you'll do your computer part. You're like, yeah, no. Alright? So let's get started here. Please, you will have a test on this. So if there are questions, you need to ask them. So let's get started here. From the beginning. Okay. So hopefully you did all this already. What we're going to do today is we're going to talk about radian measures, how to convert those between degrees and radians, and then finding function values for angles, not in degrees, but in radians. So the biggest question I get is, what is a radian? Well, think about measuring things, okay? If I wanted to measure from where I'm standing over to the wall, you can measure that in inches, you can measure that in feet, right? Correct? And of course, when we think about degrees, we're thinking about rotating around the circle, correct? Okay, so rotating around. Now, what if I told you, hey, you know what? I was traveling in a circle, and I traveled 90 degrees. Well, what's interesting about that is you can travel 90 degrees in a very small circle. You can't even see that, can you? In a small circle, I can travel that in a large circle. I can travel it even larger circle. The size of the circle can be whatever you want it to be. And I can still travel 90 degrees, correct? The point is, what distance did you travel? Was it a small circle? Was it a large circle? Was it a big circle? Well, I can't. Just 90 degrees alone doesn't help you. So you need to be able to convert that into an actual distance that we can talk about. And that's what radians are. Radians is a way for me to talk about the degrees we're talking about and talk about them in respect to something that's actually solid that I can measure out with my tape measure and 16 little dash marks on it, right? So, 16, right?
16.
What did I say?
Or 32nd.
So that's all that is. A radian measure is simply a distance that you can measure, okay? So it's taking the abstract degrees to something more concrete, which is an actual distance, okay? So don't get crazy about that. An angle with a vector at the center of a circle that intercepts an arc on the circle equals in length to the radius of the circle as a measure of 1 radian. Okay? So, let's get rid of that. Let's move on. Transferring or converting degrees to, and actually before I go there, I should just do it over here first. If I want to convert from degrees to radians, all you have to do is multiply, and depending on which direction you're going. So, I'll talk a little bit about this circle here. Everyone knows that this point is 0 degrees, correct?
Yes.
And if I travel over here, how many degrees is that? It's 180 degrees. Now here's the magic and where it happens. I'm going to use a different color to do this in radians. This represents 0 radians. So if you've traveled 0 degrees, then you've traveled 0 radians. Make sense? Okay, magic happens here. Let's say I did travel a whole circle all the way across. I traveled 180 degrees. I have traveled pi radians. I have traveled pi radians.
Why pi?
Why pi? You remember the distance across the circle, the circumference thing?
Pi times. Yeah.
Has to do with that. Okay? You know how it says 2 pi r? But that's the whole circle, isn't it? Okay? So, since you brought it up, why that? 2 pi r. If I travel the whole circle all the way around,
Half is.
That's simply 2 pi. Because if 180 is pi, then going all the way across is 2 pi's. And what this r does, in addition to that, is tell me how big the circle was. Do you see it? So if this is circumference, then 2 pi is simply tell me that you did a full rotation all the way across, and r is going to tell me how big that circle was. So that makes it clear to me what distance you're traveling. Okay? But the one we want to know about, because that's what's going to help us with our conversions, is that pi is equal to 180 degrees. Because we don't want to make numbers bigger than we need to, right? We don't want to worry about 2 pi's. 180 degrees is equal to pi radians. Everyone got that? Write it down. 180 degrees, pi radians. So if you do want to convert, don't work for me, mouse. Don't work. Don't work. Yay, good,
So
good
it's
mouse.
just equal to pi 180?
Yes.
Go back. And then the 2 squared is 360?
What's 2 squared?
Or 2 pi, I mean.
2 pi is 2, yes, it's a full rotation.
So 2 pi is 360?
Yes.
And then 2 pi r is 0.
Circumference. That's a circumference form. Don't even worry about that. Someone asked me why a minute ago. Why pi? Why 2 pi? That's why. Okay.
So every time
You see the geometry coming in, connecting? Awesome.
So every time there's a number like number greater than 1 in pi, that means that's the amount of rotations.
Right, that would be the radius technically. Because you can only make 2 pi rotation. If this is 2 pi, then I made 1 rotation. If I say I did 3 pi rotations, then it was a full rotation and then half of 1. Make sense?
Yeah.
But here's where the key lies right there. That's the important part. 180 degrees equals pi radians. What's up?
So if you like make like a 1.5 rotation, it'd be like 1.5 pi.
Well, let's talk about that since you're already asking, and the other slide is pretty much that. If I wrote how many degrees, you're going to want to give me a degree measure, right? You don't want to just make stuff up. You're saying, what if I rotated 1.5, like here?
Yeah.
Well, how many degrees is that, people?
270.
270 degrees, right? So here's where the magic happens. 270 degrees. How many degrees in pi radians? There's 180 degrees. Notice I want these to cancel, and there's pi radians in that. So what's going to happen, I'm going to multiply this. 270 pi over 180 is technically the correct answer, except what do I need to do with this fraction?
Simplify.
Simplify it. So this would go away. 9 goes in there, and 9 goes in there, doesn't it? So that point is 3 pi half radians. You're done. That's it. So 270 degrees is 3 pi half radians, or 3 halves pi radians. That's it. What's up? Move. I've heard that before. Don't do it. Don't do it. Now, you can also go the other direction, right? Oh man, you know, I traveled pi third radians. What? Yeah. Don't let that confuse you. What's pi?
3.14.
3.14. What's 3 divided by 3?
1.
1. So it's 1 unit. I've traveled about 1 unit.
But is it
Okay?
180?
So don't get all trippy about that real quick. No. Pi is 180, right? So you look at you. You're so smarty. She's already figuring it out without even doing anything. This is my radian measure. I want to go to degrees. So I want to make sure degrees on top. How many degrees? 180 degrees for pi radians. Pi's are gone. What's 180 divided by 3?
90.
It used to be 90. Now it's 60. So I've traveled 60 degrees. That's it.
So pi over
It's a
3
joke.
is
No,
60?
ignore that. It was never 90.
Yeah.
It was. He was like, what?
When did this change up?
Do you see how I did the conversion the other direction? Not so bad? This is kind of like when you changed feet to inches, remember? Feet to inches, miles to feet, all that good stuff. That's all we're doing here. My converter is this key right here. Pi, 180 degrees. See that? Pi, 180 degrees.
So when you get problems like that, all you're doing is converting them to degrees.
And we will, so slow your roll, okay? So, you guys saw this already, we already talked about it. If I want to convert from, what?
Wait,
Yeah, can you leave that one?
So that division over pi and 180, you're gonna use it so that we can convert it.
And then it's times the degrees, right?
Right.
So that would be.
Huh? No. No degrees. You can go kick it, circle K.
Wait, how many radians would be? So
Are we good here? There's more, guys. This is just me presenting. Don't make me teach the lesson here. I've got other slides that have more problems on it for you to try, okay?
This is what you count.
They are great questions, they are, but let's get through the whole thing, and if we don't have those answered yet, then we'll answer those, okay?
Wait, this is pre-count?
Welcome to pre-calc. Okay, moving on. So these are the two converters, right? If we're gonna go from degrees to radians, this is probably what you'll be multiplying with. If you're going from degrees to radians, this is what you'll use right here. If you're going from radians to degrees, here's what you're multiplying by. So, radians to degrees, and this one is degrees to radians. Okay? Yeah.
Come here. I just want to make sure I have my notes right. So if you pile your radians, right, so they'll cancel. Divide by radians and
Oh, pi radians?
yeah.
Pi radians is just 180 degrees.
Oh, so
Yeah, that's all you need right there. That's all you need to know. See right there what I've circled?
oh yeah.
It's pi over 180, and I like to put the degrees on there. So that's the converter for degrees to radians. This is the converter for radians to degrees. We good? Boop, 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 boop. Boop, 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 boop. I just want to say hi to first hour. First hour.
How come you don't convert anymore?
That's a great question. Why don't I record anymore? Huh? I didn't lose enthusiasm. I told you guys, when you quit me, I quit you. Well, no one's watched videos, so I stopped doing that. That's a waste of time. And then, and you've seen the way you guys behave. I don't need to tell you.
Okay, change subject.
I'm just answering questions. ¿Qué pasó? I'm sure you can.
Yes. I'm making sure I'm not just seeing a black dot. Kind of looks like one.
Here?
Yes, that is a degree sign, right?
I added that. Yes, correct. I said I like to use the degrees.
Okay.
You are correct. Moving on. All right, cool. Here we go. Go ahead and try these yourself for now, and then we'll check them. So go ahead and convert. These are all degrees to radians. And I will take the attendance. Got Mrs. Gavin missing? You okay?
Yeah. She's just taking her.
I think that's everybody. fraction, that ratio. No, don't do it. That's hard.
I think you got it.
It's right degrees.
Right so fast, you'll break your wrist.
What times 5?
Oh my god.
Good job. Come on. Don't be fooled. Don't be fooled. I like to take my time. Pay attention to detail. Eso, yala, chacamona. That's perfect. That's just fine. That is just fine.
You want the decimal
Okay,
place.
so you can do it by hand too.
You want the decimal place, right?
There should be no decimals. Yeah, that one's a little weird because, well, they're both units. You can still divide by 2.
Hold on. Because I'm asked 5.
I think you should just do that divided by ass. Since they're the ones that put the decimals in. 10 divided by 1.
Everything.
Don't worry about Let's see what they say right now.
Did you not write down this?
Yeah, you can pile alone. Don't touch pi. Okay. You can pile alone. Guys, you can pile alone. Don't touch pi. We'll see this, what they do with this one. Okay, ready? Ready? The first one, did you get 4 pi radians?
Yes.
Well, that just jumped the wrong way. What the heck? 4 pi radians for the first one, yeah? Second one?
Negative pi over 2.
How's it? Whoa, that's weird.
Process.
Why are you jumping like that? Negative 3 pi half radians. Right? You're going to multiply by pi over 180. Last one. And on this one looks like, since, here's kind of the rule, since there is decimals in this degrees, you're more than welcome to go ahead and multiply everything out. Because it's going to have decimals in it regardless. I would, just because it's already a decimal.
Wait, keep it, please.
See, I got a decimal place
For the last one?
yeah.
Then that's fine. But up here, since these are exact, I would leave them as exact solutions. That makes sense? If you want to be the one to bring decimals into this, I will answer your decimals.
Okay, because I just plugged in 3.14 for pi. I didn't know we were supposed to leave it alone.
Well, 3.14 pi, that's not even exact. If you're going to use your pi button. Okay? Or 22/7, which is more exact.
Okay.
Mm-hmm.
Do you have
A gumdrop? I do. Well, I only have one. If I give it to you, I have none.
Wait, so for the.
Math.
Never mind. So for the decimal ones, we can do it on calculator, right?
Yeah. Punch that whole thing in there. Yeah.
But for the other ones, we have to do on paper.
You could probably get some help with it, but I would do it by hand. Because you push the wrong button, you know, I don't know. No mercy, bro. We're good here? Everyone okay with that process? Hip hip hooray?
Does it get hard?
When I try to divide 45 into 180, I get 25.
Multiply by pi now. So there should be a pi button. Okay. This is radians. Go the other way now. These are radians. Go the other way. Go to the degrees. Four of them is 180. Oh, wow. I think this is 45 degrees. And I think this one is going to be negative 330. Oops.
You still have the 9. How did you get 45?
Yeah, you still have the 9.
Yeah. So that's 405.
Yeah, you're wrong.
Oh, because, yeah, well, here, do this. Take that and add 360 to it.
Take what?
Look, here's what I did.
5.
If 4 pi fourths, that's 180, right? 8 fourths is 360. I did the remainder, which is 45. So what's 360 plus the 45? 405.
Wait, what?
You got. Just don't listen to me.
Don't listen to me. I'm playing with these numbers. Do your own thing. I'm just playing around.
So you're wrong?
He was right, but he did it different.
I was wrongly right. Right and wrong.
I was wrong to say I was wrong. I probably was right.
Yeah. Yes.
I thought he said that was right.
No, for these. Oh, there it is. Okay, no, you're good. It's 9 pi quarts, right? Yeah, so just finish it up. What's 9 times 2?
I got 405.
Yep, I just.
I started.
Okay, is this one right? Oh, no, you have to do it. You have to convert this to this. Like that.
Oh, yeah.
Look at what. Ow!
Why'd you do the ones before that?
Because you do this.
Look, you're going from radians to degrees now. So now it's going to be 180 degrees on top. And then pi radians on top. Cancel. 9 times 180.
That's it. It is 405.
Every day I'm struggling.
So you time that by that, and you get transit. Okay, the pies cancel out. There you go. So it's 9 times 180. Close. 9 times 180 divided by 4 equals 400. That's your. Your answer is 400. Oh wait, I'm confused. 9 divided by 4 equals
What you want?
I got it. I got it.
I told you no, I'm married. Leave me alone.
Yeah, that's all.
You know the videos of it's in my room, they're all hilarious. It's so stupid. I'm gonna stab both of you guys.
Whoa! Stop with the threats.
Nicely.
Well, see, you said nice. Yeah.
Did I get it right?
Alright.
No, can I have that for like I'll just shoot you like an idiot.
Mr. Marcos, can you check please? Thank you.
314. What?
Whatever your 5%.
405 degrees, negative 150 degrees,
Oh, yes.
Yeah.
and 250 degrees 15, aka 240 feet, aka just DMS it, commentate, commentate, commentate.
I got the second one.
Huh?
What did it say? Two?
As this, you mean? Yeah, that'd be fine. But just understand that if MATLAB says, enter your solution in degrees, minutes, seconds, then you need to go the extra mile and hit that DMS. Okay. If we need to come to an agreement, you are now welcome into that agreement. If you are not given a specific unit of measurement, then you need to know, or it is understood, that it's in radians. It's in radians. Okay. Save on. Next Friday? Next Friday? Okay. Chocolate rain. Wow, you guys, that's so exciting.
What?
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 Cool. Here are some some recurring numbers that you want to know and memorize. 0 degrees is 0. Radiant is approximately 0. When we're talking about radians, 90 degrees is about pi halves. 180 is pi. 270 is 3 pi halves. And 360 is 2 pi. You also want to know the 30s, the 45s, and the 60s. Okay? Now, here's a dead giveaway. Just so you guys know. If your denominator happens to be a 4, then it's some multiple of 45 degrees. If the denominator is 3, it's some multiple of 60. If it's the 6, then it's a multiple of that. And if you're talking about halves, then it's going to be some multiple of 90. So it's going to be 90, 180, 270, 360.
So it has to be a multiple.
No, not necessarily. I'm just saying these are the most frequently used.
Common.
The most commonly used. Correctamundo. Stop. No. This is just a handful. In the infinita, that is a circle.
Oh my gosh, I can't even tell. Did you say Radian Measure?
No, these are just, I'm just saying these are a few that you need to know. You want more?
No.
Bob.
Go back.
And that's just only a handful. In the world, in an infinita, in an infinitesimally huge amount of radians. Big, beautiful radians.
Wow. Okay. Is that pi over 6? What else is it?
No, it's pi over 6.
Oh, the people are going. Because you put the circle like right on the line. So it's like all these people. Okay, go, you did this.
Big, beautiful circle. All these beautiful radians.
White So can we write that all in like one view instead of this and this?
No. I'll show you what to do right now.
So do it like this and this?
Okay, hold on. You know what? I'm gonna, I got time. What time is it? We got lots of time, huh?
240.
What?
240.
Oh man, that's beautiful. Look, here's what I'm gonna do. Instead of killing this, because here's the next slide, and you're going die.
I wanted the go back.
This?
I'm not done.
I'm not done yet.
Grab your iPhone.
Why? If I can just finish it.
No tengo dinero.
I'm gonna suck.
Y nada queda. You know what? You'll get these again. I promise.
Actually,
Hold on.
I'm on the last one.
I'm picking the back.
Wait.
Yeah, I wanted to see.
Que Dios los ampare.
Oh, I can't see it.
What now?
Okay, then.
Okay, I'm done now. Wait.
No!
Someone didn't draw yet.
You know what? I'll just let you write the circle then. Here.
Ay, Chihuahua.
I told you they were there.
I got you.
The circle's
Here.
Wait,
Let's
go 2 seconds.
slow your rolls.
Why are we aiming the slide?
Slow your egg rolls.
I want egg rolls.
It's so long, huh?
Those low-key sound
Shrimp
good.
fried rice,
I want sushi.
orange chicken, shrimp fried rice, egg rolls,
Wait, can you go back to the circle?
walnut shrimp.
I was,
No, we're gonna do.
Steak and shrimp.
We're gonna do.
but I wanted the fancy one.
We're gonna do it. We're gonna do the fancy one.
It's Can you calm down?
What are you OPO?
Just get yours.
I have a picture of your mom.
What'd you say about my mom?
I think I heard Gavin say.
I didn't say, damn.
Oh, wow.
That looks good.
Did you do that with your finger?
I did. This one.
Can you draw that on my paper?
No. Unit circle. We've already talked about the unit circle. So let me show you some of the important things. This one I'm going to draw here. I'm going to just go about 90 degrees, every 90 degrees. Okay? And here's actually where the numbers come from. This is 0 radians, correct?
Yeah.
What's on the other end?
1.5.
Pi radians. We're talking radians, people. It's pi radians, okay?
Radiant.
If I only go halfway, then how much of pi do I have?
Half pi.
I've got half of pi, or pi halves, pi over 2. I'm just going to write it as pi over 2. Pi, wait, what happened to my, oh, I know what it did. Pi over 2. Okay, so that's 1/2, 2 halves,
3 halves.
beautiful,
4 halves.
3 halves, and this would be
4
halves, aka
0.
2 pi.
Oh, let's try 2 there.
Right, 4 halves pi, also known as, 2 pi. Make sense? Questions on this? Does this circle make sense to you?
Yes.
Good. Now, if this is 1 unit, then what is the coordinates there? We know these. What are they? 0, 0. Jeez. Just kidding. 1, 0. Sorry, 1, 0. What are the coordinates up here?
1,
0.
0, 1. Did I do this one right? Yeah, I did. 0, 1. What do we have over here?
Negative 1.
-1.
0.
0. Down here?
0, negative 1.
0, comma, -1. So there is that part of the unit circle. These are all your 90s. These are all your 90s, okay? Are we good? You should have been drawing with me, right?
No, because I can draw and pay attention.
No, I'm going to do another. This is going to go away, so get your pictures in.
Well, I can't draw
Well, here,
and
let me give
look
it-
at you. I gotta look at you.
Where's your phone?
I can't
Oh, you know what? It's being recorded. Go back, go to YouTube and play it.
That's a lie.
He literally turned it.
You just said you didn't want to record it.
Stop. He turned it on.